So let us now talk about variance and covariance. So notice that covariance of x comma y, this is given as expectation of x times y minus expectation of x times expectation of y. So instead of y, if you plug in x, you get expectation of x square minus expectation of x whole square. But this is nothing but formula for variance of the random variable x. So variance of x is nothing but covariance between x comma x. So say you're given two random variables x and y. We want to compute variance of x plus y. So by directly using the formula of variance, you have expectation of x plus y minus expectation of x plus y square. So remember that. So another way to compute variance of x was expectation of, so you had x minus expectation of x square, and when you expanded this, you got this result. So now instead of x, you have x plus y. So instead of x, now you put x plus y. Now you just expand this. This becomes x minus expectation of x plus y minus expectation of y. And there is a square here. So you square this term, and then you square this term, and then you say 2 times this term multiplied by this term. So you square the first term, you square the second term, and then you have 2 times, since 2 is a constant, it comes out. You have expectation minus x minus expectation of x times y minus expectation of y. That is this term and this term. Now this expression should look familiar. This is nothing but the definition of covariance of x and y. And this is variance of x, this is variance of y, and this is covariance of x and y. And that's precisely what we write. Variance of x plus variance of y plus twice covariance of x comma y. Now if x and y are independent, then you know that covariance is 0. So if an x and y are independent, this covariance would become 0. So you get variance of x plus y is equal to variance of x plus variance of y for independent x and y. So in particular, if you have n independent random variables, then variance of x1 plus x2 plus x3 all the way to xn is nothing but variance of x1 plus variance of x2 all the way to variance of xn. So let us see an example. So in a Bernoulli trial, so say y is the Bernoulli random variable. So that is, it takes two outcomes, 0 and 1. Probability of 0 is 1 minus p. Probability of 1 is p. So variance of this variable is expectation of y square minus expectation of this y whole square. Now y is 0 and 1, and y square is 0 square is 0, 1 square is 1. So y and y square look exactly the same. So y is same as y square, because y is 0 and 1, and if you square it, you still get 0 and 1. So expectation of y square, you write expectation of y, and you know expectation of y is p, and then you have minus expectation of y square, that is minus p square. Now as we mentioned before, binomial random variable with parameters n and p is simply x, which is sum of n Bernoulli random variables. So this is an important fact, that Bernoulli random variable is same as summing up n independent Bernoulli random variables or n independent Bernoulli trials. So what is variance of x? So variance of x is variance of x1 plus variance of x2 all the way to variance of xn. So we are using this formula right here because we are using n independent Bernoulli trials. Now variance of this each of these variables is p minus p square, which is nothing but p times 1 minus p. Similarly, variance here is p times 1 minus p, and so on. And there are n variables. So you add up p times 1 minus p n times, you get np times 1 minus p.